Welcome! This is the third in our series of interesting Excel files. This example is about using different criteria to automatically summarize data in useful ways. Once again, you can download the example file by following the link in the video description. In this specific case, we have a range of invoices from a mythical company. Each invoice has a number of attributes: the project, the department, when invoices are raised and when they're settled, and so on. We want to be able to see the data in a variety of different views. This sounds complex, but if we see the spreadsheet in action, it'll be easier to understand. Here is one of the views of the data. In this case, we are looking at a list of projects. As you can see, the Firefly project goes through the whole development cycle, while the Coyote project misses out the first two phases and starts with the design. Look at the Lion project here. It has done the first three stages, and now we want to add a test phase. Moving to the Register tab, we select the Lion project for the Bravo client. We also select the test phase, then we fill in the date and the amount, and we add the invoice. Back in the Project tab, we can see that the test phase is now filled in. What if we want to create a brand new project? Let's create a Kiwi project for the Charlie client. On the Register tab, we can type in Kiwi as a new project name and fill the rest of the attributes. Once we've registered a phase, notice the name Kiwi is no longer valid as a new project name because we already have a project called that. But we can select it from the pull-down to fill in the details of this second phase of the project. Now, on the project page, we have the two phases of Kiwi. Let's look at another view. Here we can list the outstanding invoices. Notice the two Kiwi phases both have outstanding invoices, as well as some for the Lion project. We can go to the Settle tab to note invoices that have been settled. Let's do that with the Lion research invoice. Pick this from the top of the outstanding invoices, note the date that it was settled, and save that. And when we look back at the outstanding invoices, it no longer shows up. And the monthly view shows that the £24,000 invoice for research was paid in July. Here's another view. In this case, the options at the top let us pick which year we want to see. We could select to show a summary of all the matching results, or a slice picking out just those items that fall into a particular year. The overall shape of this spreadsheet is pretty obvious. We have a worksheet that holds all the raw data, a list of invoices in our case. There are a couple of forms for the user to enter stuff, one defining new projects and invoices, and another for noting when invoices are cleared. Then we have a number of different views that each present a different summary of the data. Finally, we have some reference data that controls, for example, which departments are selectable. I'm not going to go through all these views. The spreadsheet can be downloaded and you can study it in detail if you're interested. I'm going to focus on just one view. The rest are pretty similar. This is the by customer view we've already seen. It can be thought of as having three parts. At the top, we have options that control what the tab shows. On the left is a list of the matching projects and some of their attributes. And on the right, we have a matrix that expands on how each project interacts with every department. In the Source Data tab, we have raw data and some hidden columns that are calculated from it. There are many different hidden columns, each related to one or more of the views. For the By Customer view, there are 4 hidden columns. The first of these creates a project code number. This determines the order that projects are shown in the tab. The By Customer view uses the large function to sort its entries, so we have to have a numeric value. Next, we have a column that only selects the codes which match the criteria set in the top of the view. In this case, only entries with an issued year of 2017. The third column ensures that we only have the first example of each code, so the view will only have one row for each project rather than one for each invoice. When we look at the view, there is a column that identifies where the project data is coming from. In this case, it is column B. Notice that every entry in the row first checks that column B has a value. If it doesn't, we're careful to make sure the cell's value is the empty string. Column B is hidden here by the simple expedient of setting its font color to white. The various attributes are calculated by looking up data in the source. The matrix part of the view is controlled by the P column in the source data. We concatenate the project ID code with the department's name. Each entry in the matrix area uses the project ID code from column B and the department name from row 3 to identify the matching entries in the data tab. Notice the formula here has a combination of cell specifiers that employ dollars to grab the correct data, whichever cell in the data is being examined. This is, of course, a made-up example, but hopefully rich enough to give you an idea. In this case, we have a single tab containing the source data, a few entry forms, custom fit to the needs of the users, and then a whole load of different views, each of which provides a 2D or 3D selection through the data. This pattern is extremely common. It is so widely useful, I've added an extra video to go into the underlying theoretical background. This should be labelled as video 3A in the series. Thanks for watching.